Okay, what we're going to do here is I'm going to work out problems 1 through 5. These are going to be the first 5 problems on your semester final review. First question, we have a graph and it says, which is an element of the range of the graph function? And they give us 4 answer choices. Our 4 answer choices are A, being 2, my handwriting is still terrible, B, being 3, C, being 0, or D being 4. The key word to remember here is range. You should remember that range represents y values. So looking here, we got to determine which y value is an element, all right? So looking here, we have to see if we have the y value of 2. We have to see if we have the y value of 2. Well, y value of 2 would be right here. It is not on this, so we do not have a y value of 2. Next one we're going to look at is a the y value of 3. So looking here, we look at a y value of 3. It is not on the graph. And we look at C. C is the y value of 0. Well, y value of 0 would be anywhere on this line right here. Sorry about that. Would be anywhere on this line. Y value of 0 would be anywhere on this line. So that could be either here or here. So therefore, C is an element, so C is my answer choice. And that would be how you'd work out number 1. Number 2, the question asks, find the zeros of f of x being equal to x squared minus 3x minus 5. Specifically by using the quadratic formula. So let's go ahead and write down what the quadratic formula is. The quadratic formula is x equals negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. All right? So we look at that, we have to remember what means what. It's also important to remember that zeros means, I'm going to write over here, zeros is where I cross the x-axis. Zeros, where I cross the x-axis. Okay? This could also be called solutions. So these are just some important key words to remember. Now, first we have to determine what a, b, and c is. Well, a is the number next to x squared. The number next to x squared in this case is a 1, so we know a equals 1. B is the number next to x. In this case, it's a negative 3. And c is the final constant, which in this case is a negative 5. This all comes from the format of assuming that it's f of x equals ax squared plus bx plus c. All right? So looking at that now it's just basically plugging in and doing some simple calculations. So we can say x equals negative b, so negative of a negative 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times a, which is 1, times c, which is negative 5. All divided by 2a, so 2 times 1. So then x is going to be equal to 3 because 2 negatives cancel out to make a positive, plus or minus the square root of 9 plus 20. You may wonder yourself, how do you get 20? Well, a negative 4 times 1 would still be negative 4. Negative 4 times a negative 5, 2 negatives make a positive, so it becomes 4 times 5, which is just 20. They're all divided by 2. All right, so now I am starting out of space, so we're going to move a little bit over here to the side, and we're going to say that x is equal to 3 plus or minus the square root of 29, all divided by 2. Now you should think to yourself, is there a way to break down the square root of 29? So we got to think of factors of 29. Some factors of 29 are 1 and 29. 29 is what you would call a prime number. That means the only factors that go into 29 are 1 and 29. Since there's nothing else I can do with my situation, my zeros or my solutions or where I cross the x-axis is 3 plus square root of 29 divided by 2 and 3 minus square root of 29 divided by 2. And that would be the answer choice C for problem number 2. Let's go look at problem number 3. A 5.5 foot tall student cast a 7 foot long shadow. At the same time, a flagpole casts a shadow that is 57 feet long. How many feet tall is the flagpole? Though we have not discussed this in detail in class, it's a simple geometry problem. So let's start off labeling a few things. I have a 5.5 foot tall or feet tall student. All right? And then I know that he cast a 7 foot shadow. 7 foot shadow. I know that I have a flagpole that cast a 57. The flagpole that cast a shadow that's 57 feet. 57 foot shadow by flagpole. And then the final question is, how many feet tall is the flagpole? Though we have not spent a ton of time over this type of situation, it's very, very simple. This is going to be a proportion problem. Basically, it's simple enough to say, we can say that student over shadow is equal to flagpole over shadow. So basically what we're saying is height over shadow, height over shadow. The student is 5.5 feet. The shadow for the student is 7. The flagpole, let's call it X, and the shadow for the flagpole is 57. So now we are going to simply cross multiply. So we're going to say 5.5 times 57 is equal to 7x. So then you have to be asking yourself, what is 5.5 times 57? Well, we'll go over here, we'll pull out a calculator, and we will say, type in 5.5 times 57. You get 313.5. So 313.5, I'm going to go up here to the top right, 313.5 is equal to 7x. So now what I'm going to do is I'm going to divide both sides by 7. So 313 divided by 7 gives me an approximate. I'm going to switch x to the other side, so I'm going to put approximately equals x. And it's approximately 45 feet. Since it doesn't tell us what to round to, I went ahead and rounded to the nearest whole number, because the actual dividing by 7 got me 44.7857, so I just round that up to 45 feet. So the height of the flagpole is approximately 45 feet. That would be the answer to number 3. Let's go on to number 4. Number 4 says simplify the expression of a squared plus 3a plus 3b minus 7a squared. This one's very simple. Basically, all it's asking for us to do is put like terms together. So we can do a squared minus 7a squared. This will give me negative 6a squared. Then we could say 3a and 3b, these two don't have any in common, so I can say plus 3a plus 3b. This would be your most simplified format. Now someone might ask, what if I wanted to factor it a little bit? So you could factor this a little bit. I'm just going to go ahead and put factor a little bit. You guys know my weird quirks. So factor a little bit. And you can factor out a 3 out of each one of them, so it can become 3 negative 2a squared plus a plus b. That's just if you want to do that. There's no requirements for that to be done. It is not a necessity. I just wanted to show you that if you wanted to do that. But the actual most simplified format is this version right here. That's how you answer number 4. Let's go on to number 5. Number 5 says simplify the expression of negative 2a squared, a to the 5th, b, and this is all cubed. So you should remember multiplying exponents from Algebra 1 and a little bit of geometry. But let's go ahead and square what's inside here. Since negative 2 and a are being multiplied, I can actually just square each piece of these. So negative 2 squared becomes a positive 4. and a squared becomes a squared. I'm going to put this back in parentheses just to keep it nice and neat. Now you should remember that if you are ever raising an exponent to another power, you multiply the two. So 5 times 3 is 15. B to the first times 3 becomes b cubed. Now it's simply putting like terms together again. We're not adding or subtracting, we're multiplying, so this will all go together. This will all go together, but we want to multiply like terms to like terms. What I mean by that is 4. There are no other regular numbers, so this is just 4. A squared times a to the 15th. Since these are two variables being multiplied, you add the exponent, so this becomes a to the 17th, b cubed. And that is how you work out number 5. That would be the answer to number 5.